Okay, today we're going to talk about the relationship between percents and decimals. So if you notice up here where the vocabulary usually is, there's two ways we can go from a decimal to a percent, and it tells me I'm going to move the decimal point 2 places to the right and use a percent sign and add a percent sign. And then if I want to go from a percent to a decimal, I'm going to do just the opposite. I'm going to move the decimal 2 places to the left and remove the percent sign. It's really just that easy. I hope you guys think today's lesson is as easy as I do. So I have 3 examples. In this first section, I want to write the decimal as a percent. So we are going to use this first rule up here. On all of these, we're going to be expecting to move the decimal 2 places to the right and write a percent sign. So if I have 62 hundredths, if I want to write this as a percent, it tells me I'm going to move my decimal over 2 places and I'm going to add a percent sign. So 62 hundredths as a percent is 62%. It's that easy. So if I have 4 and 2 tenths, okay, well I'm going to take that decimal, I'm going to move it over 2 places to the right. Now I have a blank spot here, and I'm sure you all know, if you ever have a little empty whoop-de-doo, add a 0. So now I have 420%. Don't forget about that percent sign. Okay, last one. I want you guys to try this one. 5. Pause the video. Write this as a percent. Kind of a tricky one. Should have got 500%. The only reason that one was a little tricky is because we did not see a decimal in the beginning. But we all know that if you don't see a decimal in the number, it is at the end. Okay, so now if we want to write a percent as a decimal, we're going to go the opposite direction. So if I have 35%, I'm going to take the decimal and move it 2 places to the left and remove the percent sign. So in 35%, I don't see a decimal, but just like with regular numbers, if I don't see a decimal, it is right at the end. So I'm going to move it 2 places to the left, take away that percent sign. So 35% as a decimal is 35 hundredths. Okay, about 235%. Okay, we're going to take that decimal, which is at the end since I don't see it, move it 2 places to the left, take away the percent sign, so I have 2 and 35 hundredths. Okay, I want you guys to try this one. Write 2 and 3/10% as a decimal. Pause the video. This time you had an empty whoop-de-doo in front of the numbers, which is okay. You just have to fill it in with a 0. So you should have got 23 thousandths. Okay, if we want to write a fraction as a percent, we have done this before. Well, let's just look at an example. If I have 3/8. Well, before, remember, a percent is special because it has 100 in the denominator, and all the ones that we did in the first section, we knew an easy way to get from one side to the next. But you might be thinking, well, I don't know an easy way to get from 8 to 100. Now, if there is not an easy way to get from your denominator to 100, and you can't simplify, we need to change this fraction into a decimal. Yeah, I know you've done this before. It may have been a while. Remember, a fraction's just a fancy division problem. So we are going to take 3 and divide it by 8. We're going to turn it into a decimal. Now I know 8 will not go into 3, so I'm going to add a decimal and a 0. 8 will go into 30 3 times, and I get 24. And we get 6 left over, add a 0, drop it down. 8 will go into 60 7 times. 8 times 7 gives me 56. And then 8 will go into 45 times, and I know it will go in evenly. Okay, once you change it into a decimal, so I have 375 thousandths, now we're going to use what we did in the last examples to change a decimal into a percent. So I'm going to take my decimal, move it 2 places to the right, and add a percent sign. So I get 37 and 5/10%. Okay, I want you guys to do this one on your own. I want you to change 1/6 into a percent for me. This one was just a little tricky because it ended up being a repeating decimal, but if you did not end up with 16 and 6/10 repeating percent, you notice that if you have 1.6 and the 6 is repeating, that means 0.166666, and if you kind of write that out, then move your decimal, you should notice that once you move the decimal, you just have that 0.6 repeating. Okay, so I can keep this all in one video. I'm going to go ahead and do this bottom example right below here. There should be a blank spot on the next page. So if you flip your notes over, there should be a blank section up at the top. My formatting didn't work out. What we're going to do is we're going to find the percent of the number. So we've done this also. If I wanted to find 20% of 150, I know a lot of you were tempted to solve these problems the way that we're going to talk about today, and I asked you to solve them how we learned in section 7.1. Now before, we learned that of means multiplication, and so I took 20% times 150, and then I wrote 20% as a fraction, and I multiplied it by 150, right? It was kind of tedious work, and there is an easier way. So what we're going to do, we're still going to take 20% times 150, but instead of taking 20%, we're going to change that 20% into a decimal. So remember, if I want to go from a percent to a decimal, I'm going to take the decimal place, move it 2 places to the left, and take off the percent sign. So now I have 2/10 times 150. Whenever you take 2/10 times 150, you should get 30. Okay, let's do 3 8/10% of 45. Okay, remember that of means multiplication. I don't want to multiply with percents, so I'm going to change it to a decimal. So I'm going to move it over 2 places to the left. So now I'm taking 38 thousandths times 45. And if we show that work below here, 5 times 8 gives you 40. 8 times 4 plus 4 gives you 36. 3 times 5 gives you 15. 3 times 4 plus 1 gives you 13. And whenever you add them all up, you should get 1,710, but remember we have 3 decimal places, so I need to move my decimal over 2 places, so you should end up with 1 71 hundredths. Okay, now right below that there is a word problem. Your word problem says only 16 teams get to participate in the NCAA Division I softball tournament. If this represents about 4.6 of the total teams, about how many NCAA Division I softball teams are there? This would be a great time to use that percent proportion we talked about in the last section, where we said is over of equals percent over 100, and also remember that we extended it to part over whole equals percent over 100. The part over the whole will probably be a little more applicable in this problem. Now remember, I said the easiest gap ever to fill in is the percent, and I see that I was given 4.6%. So I'm going to put 4.6 over 100. Now I need to figure out where I'm going to put this 16, because it's the only other number I'm given. That says only 16 teams get to participate in the NCAA division. I'm asked to answer about how many NCAA Division I softball teams are there. So let's think. Is this 16 teams, the given information, is that a part or a whole? Now hopefully you identified that it is a part. We are actually looking for the whole. 16 is just part of all of the teams. Now that I have my proportion set up, we know many ways to solve a proportion. So if I cross multiply, I can take 16 times 10 and I get 1,600. X times 4.6 is just going to stay 4.6x. And if I wanted to solve for x, I would divide both sides by 4.6. Okay, so go ahead and pause the video. I want you to divide this out and see what you get. Hopefully you ended up with about 348 teams. Now it wasn't exact, it didn't come out to a perfect even number.